Welcome back to our last session for today before we move into the awards. The session we're going to have now is a case study session. It's going to focus on operation and maintenance in thermal power plant, a case study on Lalitpur Power Generation Company. Requesting Mr. Mayank Mishra, Head of Operation Efficiency Department, Lalitpur Power Generation Company, to join us and make his presentation. But before he kicks that or gets started off with that, a few words about him. Mr. Mayank Mishra is a seasoned professional with over 21 years of experience in the power business. He has worked in several prestigious organizations such as Nuclear Power Corporation of India, BHEL, L&T, and GMR. Currently, he is serving as the head of Operation Efficiency Department at LPGCL. He holds a vast experience in power plant operations, efficiency, and commissioning. Mr. Mishra, welcome. Request you to unmute and start your video. I hope you're able to see my screen.
I am able to see.
Perfect. So you could get started and you could just indicate when you need me to change the slide. Yes?
Okay.
Okay, over to you.
This is, I will presenting the operation maintenance in thermal power plant and from the behalf of Lalitpur Power Generation Company Limited. Please change the slide. First of all, I will discuss something about the Bajaj Group. Bajaj Group was founded by Sri Jamnalal Bajaj, a freedom fighter and philanthropist and a close confidant of Mahatma Gandhi. The Bajaj Group is one of the most respected and renowned business house of India. The journey started 8 years back with the sugar factory in Lakhimpur Kheri, Uttar Pradesh. With growth as the ultimate vision, the group has diversified into a variety of businesses areas like power, sugar, FMCG. So, our next slide, please. This is the overall about the power sector, power group. We are having the total capacity, installed capacity of 2,430 megawatts, and we are having total 6 number of power plant. Out of these 6 number of power plant, our first power plant is Barkera, then Makstapur, Kambarkera, Utrala, and our one of the biggest UP biggest power station is Lalitpur Power Generation Company Limited. It is Lalitpur, situated in Lalitpur, and it is having the installed capacity of 80 megawatts. So please change the slide, share. I will tell something about the LPGCL. Lalitpur Power Generation Company Limited, 3 into 660 megawatt, is subsidiary of Bajaj Group, is located in Lalitpur district. It is a first supercritical thermal power station of capacity 3 into 660 megawatt in Uttar Pradesh, and it is having the very high reliability and efficiency. LPGCL is placed among one of the best coal-based thermal power station in the country, and it is made with the very high reliability, efficient operation, and this particular fact has been affirmed by the UBPTCL also. And we are having land acquisition of 1473 acres of land. Our nearest highway is NH 44, around 22 kilometer away. Our site is located. Unit capacity is 3 into 660 megawatt. Coal consumption, coal requirement daily is 28,000 tons. Gross power production is of 47.52 million units. And we are having the 765 kV transmission voltage. Apart from that, we are having the 220 kV also. Switchyard is there for the startup power. And we are having the 100% PPA with the UPPTCL and Uttar Pradesh. Please change the slide. And then accolades and recognitions. We are having the NABL accredited coal testing lab. Also we are having the ISO 9001, ISO 14001, ISO 45001, and ISO 50001 certification. Please change the slide. This is general process overview of any of the thermal power plant. If we see the boiler is supercritical boiler, and it is having the capacity of 2110 TPH of steam flow, and it is main steam temperature design temperature is 568 degrees centigrade, and the heater design temperature is 595 degrees centigrade, and we are having the Siemens made turbine. It is having the 3 cylinders, HP, IP, and LP, and we are having the condenser, and as also we are having the pulverized coal firing system. That's all. Please change the slide. Innovative in-house projects and best O&M practices. Please change the slide. As you know, as evacuation with the railroad, our first topic is there. In India, the major source of electricity is a coal-based thermal power plant, which contributes about 75% of total power generation. In the process of power generation from the coal-based thermal power plant, huge quantity of fly ash, 30 to 40% is generated. And also it is depend upon what is the quality of coal you are firing. Eco-friendly utilization dispose of fly ash is major challenges among the coal-based thermal power plant. The fly ash is a solid waste causing environment pollution if not disposed properly. It is also having the environmental effects, also having the various deteriorating effect of the environment. So our milestone achieved with the 100% fly ash disposed to cement and other industries. So ये हमारा 100% fly ash का disposal हमको करना है. ये हमारा एक one of the objectives है. But due to limitation of transportation of fly ash to the road distance of the cement industry from LPGCL and incentivized rate of transportation by railway. So major if you are seeing this particular plant location, it is located in very remote place in the Budelkhand region of UP. So our connectivity with the road is very limited, and also nearby cement power plant is very limited. So we have to transport, and this due to this fact, we have to see some mean for the transportation of our fly ash. So for this, Railway Department has subsidized the freight in the month of August 2020, and LPGCL started searching the possibility. As agreed with the Railway Department, we have dispatched first rack to cement industries in the end of month of October 2020. Initial loading time is very high due to manual loading and right selection of tools now, and subsequently with the right selection of tool and process optimization, we are able to achieve the 6-7 hours for the loading of the rack. In the process of manual loading, OHE line also created problem for us for discharging or the rack within the time, and also the only open type accepted racks wagons are accepted here. So all these challenges LPGC are able to counter, and after that, before loading of the fly ash, it is we are doing the conditioning also with the 6-7% of the moisture, so that environment very small particles, fine particles of ash will not disperse, and wagons are covered properly with the tarpaulin and tied to avoid spillage of the fly ash from the racks. Railway also has taken the LPGCL in motion way bridge under freight operation information system FOIS, which eliminates the problem of weighment which was done at Kota and Jhansi railway stations, which is approximately 100 kilometers from the plant location. By doing all these things, we are able to, if you are seeing the data, then in the financial year 21-22, total 155 racks, 35.46 of the total flyers we have dispatched to the rail, and subsequently in the current financial year 261 racks, approximately 50.02 total flyers generated we have dispatched to the fly through the railway mode. So these kind of achievement we have able to do. Then please change the slide. Share. If we say the mode of ash supply dispose, so through the rail route of the cement industry, 49% of the ash we are able to dispose, and through road to cement industries, we are 30% we have doing the disposal, and 3% we are doing the bricks and industries, bricks and other industries. 18% in the bottom ash we are doing the disposal. So all these things we are able to provide the eco-friendly disposal, helpful in compliance of the regulatory requirements, cost effective as disposal, highly helpful in plant operation for meeting the meeting the normative requirements, and improves the revenue for the railway also. So this particular we have taken into the positive approach of the disposing the um, our fly ash with the rail, which was not envisaged in the design. So we are able to achieve the sustainability in the ash disposal and meet the requirement of the environment and normative requirement of the UPPCL and various regulatory authorities. So, Shreya, please change the slide. Now coming to next topic, we have provided the CW pump interconnection. So nowadays in the design we are having the various a lot of margins we are having, and one of the margins we have noticed that we are having the whatever the flow requirement for the generation of condenser vacuum in the condenser, that can be fulfilled by the less than the design pump operation, whatever the things are there. But there is a problem. We are having the 3 units, and each unit having the 3 pumps. In the design, all the 3 pump operation is envisaged, and so we are having total 9 pumps. But we have seen that with the 9 pump operation, we are having the we have to whatever the condenser vacuum also very coming down, and with the 8 pump operation, the sufficient economical condenser vacuum we are able to maintain. Our design is 1.1 kc, and our as per the calculation and other economical factor, we are able to generate the 0.01 0.08 kc absolute pressure with the operation of 8 pump, without the operation of 9 pump operation. So this is achieved by doing the interconnection between the different units. That is not previously not in the design. So we have planned this particular interconnections, and this interconnection we have done with the installation of in-house. We have done all the things. We have properly planned all the activities. So due to this particular innovation and correction in the design, we are able to save a lot of APC. So we have estimated that in the financial year 2020, 2021 and 21-22, about 5.22 crore rupees APC we have saved with the operation of this. And also we have not compromised with our condenser pressure. That is very important thing. Our condenser pressure is 0.08 absolute units, and we are this particular pressure, we are economical pressure we are maintaining, that is less than our design pressure 0.1. So we can say that there is a lot of margin in the design is available. So in order to improve our efficiency, reduce our APC, we can utilize that particular margins, and we have to see all the available margins. So this in-house, this particular modification in-house, we have done everything, and all the materials are available during the construction phase that we have used. So that is a huge saving in APC reduction. About approximately 0.1% APC percentage APC station APC we have saved by this. So yeah, next. Then coming to next, star delta connection. Power in delta connection in 3 times greater than that of star connections. So motor which are having the margins in the starting torque can convert it in star connection. Total 5 number identified and successfully implemented in the projects. So we have identified all the motors which can we can change change the connections. So clinker grinding motor, LP water pump motors, silo fluidized blower motors, LP seal water pump motor, and HP seal water pump motors we have identified, and we have changed these particular motors connections. So total we are having the saving of approximately 1.43 crores. Then one of the most important Pantone-based dredging deck for the reclamation of the ash from the recovery pond. That is one of the more innovative idea we have seen here. The problem is that due to limited area of ash dike in LPGCL, the residence time of the ash to settle is very less, which resulted carryover of ash particles through fume pipe into ash water recovery pond. These particles get accumulated in the ash recovery pond, thereby limiting the buffer capacity of recovery pond. So for the mitigation of the problem, we have accumulated ash removal from the pond is must to enhance the buffer storage capacity of the recovery pond. To mitigate our problem, 3 possible alternatives were explored. First is manual removal of ash from after dewatering, removal of ash by porcelain of external agencies, removal of slurry with the dredging pump with the agitator arrangement floated on the pontoon based movable deck in recovery water pond. So option 3 we have utilized there. So uh, we have decided to go for the floating pontoon along with the dredging facility. In order to optimize cost of the system, it was decided to in-house design and develop a pontoon-based dredging deck for the removing of the slurry. Pontoon, being floatable, can be moved to various locations in the recovery pond with the flexibility of hosting with the dredging arrangement based on the variable depth of the slurry to be removed at the bed. By doing this, we are able to rectify the problem. So one of the this we have then coming to next slide, Shreya. These are the various summary of various in-house project innovative products energy ideas we have done. In-house CEP de-staging also, apart from the CW, also we are having the CP de-staging in-house we have done here. So that is also by doing the de-staging approximately 12,000 megawatt hour per yearly per annum we have saved. So 3.67 crore rupees of saving estimated, and the replacement of HFO with the LDO system. LED replacement we have also we have done various because our the boiler lightings are not LED, so we have replaced plant manner all the LED lights. Interconnection of the MRS and plant service here kept in service, resulting in stopping of MRS compressors that we have done. And variable frequency drives and LDO forwarding pump we have done. So approximately 86 megawatt hours we have saved. So total amount of saving is 13.98 crore rupees. So can you move to next slide? Thank you thank you all the panels and jury members. Thank you. That's all from the Bajaj
Thank you.
Energy
Thank you,
Limited.
Mr. Mishra, for that presentation. In fact, a quite detailed case study. Any questions from our attendees for Mr. Mishra? We could take that up now.
Yeah.
Again, I've seen that an attendee has raised hand. We would not be getting your audio video on, so you could key your questions into the Q&A box. And of course, this would be followed by the CEE awards that are going to commence at 3:30 sharp. Okay, we don't see any questions coming in, but yes, in case there are any questions, I could have them answered by Mr. Mishra and pass them on to you. So you have your time and you could key in your questions. Thank you once again, Mr. Mayank Mishra, for your time, and have you join us at the awards at 3:30.
Thank you,
Thank you. Thank
Shale.
you.
Thank you.
Yes.
Okay.
Bye.